Alright, good day guys. Today I want to discuss question 3 from the 1819 Pspm for the SP025 course, which is the physics course. This is in the semester 2. Alright, so let's look at the first sub-question, which is calculate the number of electrons that flow in a wire if it carries a current of 2 amps for 5 seconds. So if you look at the definition of current, it is the number of charge that passes through a particular point in a given time. I can rearrange that to get Q equals to IT. Alright. Now, at the same moment, the total number of charge that passes through that point is equal to the total number of electrons that passes through that point and the electron charge. Okay, I can equate these two and have this form. So IT equals to NE. Because I'm looking for the number of electrons, I can rearrange this equation into N equals to IT over E. Alright, so IT is merely 2A multiplied with 5 seconds. Okay, both of that divided by the electron charge. You can refer to your constant sheet at this point and know that electron charge is 1.6 times 10 to the power of negative 19 coulombs. Alright, okay, now so at this point you can press in your calculator and find that the number of electrons is actually 6.25 times 10 to the power of 19 electrons. Okay, so this is your answer. Now let's look at the second sub-question. A 2.5 kilowatt heater is connected to a 220 volt power supply. Right? So there's 3 sub-questions. Let's look at the first one. Calculate the current and resistance in the heater. Okay, so just to remind ourselves, power is equals to the current multiplied with the voltage. And with that said, I can rearrange this equation to get current equals to power over voltage. Okay, so that is 2500 watts over 220 volts. So I have a current of approximately 11.4 amps. Now, at this point, it's useful to remember that V equals to IR. That is Ohm's law, right? Ohm's law. I can calculate the resistance here by dividing the voltage with the current. Okay, so the voltage is again 220 volts and the current is 11.4 amps. That would give me a value of 19.4 ohms. Okay, now the second sub-question. The coil of the heater is made from a wire with a cross-sectional area 2 times 10 to the power of negative 7 meters square. Okay, good. And resistivity, so rho, equals to 1.1 times 10 to the power of negative 6 omega meters. Calculate the length of the wire. Now, we should note at this point that from the previous question, we know that the resistance is equals to 19.4 ohm. Okay. And if you refer to your equation sheet, what you will find is an equation relates these 3 and as well as with length variables. So I will have R equals to rho L over A. Rearranging this, you will get L is equals to RA over rho. Okay, substituting the values. So that means R is 19.4 ohms multiplied with 2 multiplied with 10 power of negative 7 and dividing that with 1.1 times 10 to the power of negative 6, right? And that would give us a value of approximately 3.5 meters. There we go. Okay, so this is really talking about how resistance is related to the material, which is resistivity, and the geometry, which is the length and the area. Okay, now next sub-question. The voltage of the power supply is then changed to 110 volts calculate the new power output of the heater. Okay, so again, let's talk about power. So I have power and I have IV. The voltage has been changed, but that also means that the current has been changed. We know what the voltage has changed to, but we don't know what current has changed to. We don't know the I new. So that means I new, we don't know. But what we do know is the resistance will stay the same. So I can express this equation as a function of resistance. Okay, so just to remind you, V equals to IR. Okay, I don't want I, so I rearrange this into I equals to V over R. And I substitute this into here, and what I will get is V squared over R. And that would mean the V new, or the new voltage, is 110 squared over the resistance, which is 19.4 ohm. Okay, this would give us a new output, right, of approximately 624 watts. Or, just to keep things consistent, this is about 0.624 kilowatts. Okay, so let's look at the next sub-question, 3C. The figure above shows a circuit with a battery having an EMF of 12 volts and internal resistance of 0.2 ohms connected in series to two resistors, 3.3 ohm and 2.0 ohm. So let's look at the first question. Calculate the current in the circuit. So I know that epsilon is going to equal to IR, or the effective resistance. This effective resistance, okay, because they're all in series, is just 0.2 ohm plus 3.3 ohm plus 2.0 ohm. Okay, so I know this effective resistance is about 3.55 plus 2 is 5.5 ohm. Okay, so once we have that, I know epsilon is equals to 12 volts. I can rearrange that and calculate the current, which is current equals to epsilon over R effective. That is 12 over 5.5 gives me an answer of 2.2 volts. Okay, so I equals to 2.2 volts. The next question. Calculate the terminal voltage. So terminal voltage means outside here. Okay, so this is the positive terminal, this negative terminal across the battery. So if you look at within here, there is a voltage drop across the internal resistance. Okay, so that means the battery, right, is able to output 12 volts, right? But this is equal to the terminal voltage, right? The terminal voltage plus the voltage drop, which is VR. Okay, so we want to find the terminal voltage or the output voltage. So that means terminal, which is equals to epsilon minus VR. Again, reminding yourself of Ohm's law. So I have 12 minus I VR. Okay, and that I from the previous question is 2.2. So I have 12 minus 2.2 times 0.2. And this gives us a terminal voltage of 11.6 volts. Okay, all right, so that is the end of it. I'll see you in the next video.